So, you've all read the session title. There's a lot of content to get through, yeah? So thank you very much for coming to the last session on the last day when everyone's energy levels and brain levels are pretty low, yeah? Hopefully this isn't too taxing. There are no demos. There are a fairly limited number of screenshots. Some of this is going to sound a bit ranty and a bit critical, and it's certainly not intended that way. Doing this kind of stuff at this kind of scale is just hard, and some of the things that I have come across are just inherent to using cloud, full stop. It happens on Azure. Exactly the same problems exist on AWS, and they exist in many, many other places as well. They're things that you probably don't think about at that kind of initial design stage, and a real kind of, as I say, a bunch of things that hopefully don't make these mistakes if you ever go in this direction. I was going to do a whole Good Morning Vietnam kind of starting to the whole thing, but apparently traumatizing the audience isn't something you're allowed to do at SQL Bits, unless your name is But Woody. So, if there's some time at the end, we'll do some... Why are you advancing? If there's some time at the end, I'll do some questions, but I will warn you, as I say, there isn't a great deal going on. I'm going to make some assumptions about some of the things that hopefully you know, yeah? If you don't know these things, there are plenty of really good resources. I'll be talking about these as concepts in the background. There's a bunch of really, really useful stuff if you're working with dedicated SQL pools. These are basically invaluable resources. Data Toboggan focuses on everything that is Azure Synapse. I'm using components of Synapse, so we're using a lot of Data Factory, some Data Lake, bit of Databricks, and a big dedicated SQL pool. But we're not actually using Synapse itself. We're using the underlying components separately, partly because we started 4 years ago, and Synapse wasn't Synapse, or the Synapse that you have now isn't the Synapse that you had 4 years ago. So the project background, it's a UK telecoms provider. A very old Netezza environment, and Netezza is basically a big rack of equipment that costs about 5 million quid, and you ship it into your data center, and there's loads and loads and loads of disks and processors and processing boards and all sorts of things. A typical kind of enterprise data warehouse, lots of little small tables, some kind of medium-sized tables, a few, a fair old number of largish tables, a few monsters, and a couple of Godzilla tables that just kill you. A big overnight load process, so that everything rocks up for 9 AM in the morning. We pitched out to do the whole thing with Azure after a few false starts with various other bits and pieces. And this is kind of what our solution looks like. All of our heavy lifting takes place in Azure Data Factory. I'll be talking about Data Factory at length. A big dedicated SQL pool, doing the various bits and pieces that we're interested in. The first thing you're going to need is an ELT framework, because you are going to be doing lots and lots and lots of things in parallel. You're going to want lots and lots of things to run overnight. You're going to want to know what ran, what didn't run, all of those sorts of things you are going to need. Microsoft does not provide a really solid ELT framework for Azure Data Factory. But there is one here that's supported by Paul Andrew, who's been speaking here earlier today. It's pretty good. In fact, it's better than pretty good. It's very good. We didn't use this, but that's because we started 4 years ago, and this didn't exist when we started. But you are going to need something of this nature. No questions asked. Pick it with care. Andy Leonard, once upon a time, told me, don't move the ETL, and I should have listened to him. This was kind of approximately the breakdown of our project. There was about 20% of it we burned doing database-related things, about 50% of it doing ETL kind of things, and about 30% of it dealing with various data type errors and data transitions. And then there was the other 50% that we burnt validating the whole thing in automation. The ETL is where all your business logic is. If you can leave that alone and just move your data and your data processing, life is going to get a lot simpler. First kind of proper dedicated pool. Yeah. resumes can take a while at scale. Yeah. When you pause, particularly if you pause through the portal, you will sometimes get a warning that there are queries running. Yeah, and that's absolutely lovely and all of those sorts of things. When you try and pause it through ADF automation, for example, you will get no warning. You will just boot those queries. If you are very, very, very unlucky, you will find that someone was doing something really, really, really big when you paused it. And that transaction will roll back when you try to resume. When you try to resume your environment, it was an hour, and I think they made it longer. There's a kind of hour-long timeout for the environment. If the transaction that you killed does not roll back inside of that hour, and some of those transactions can be so big that they will not roll back in an hour, yeah, basically, your environment won't resume. Just won't resume. You've got to call support. Support have got to change the timeout on it, and then you've got to push the resume button and cross your fingers and hope that it goes. How do I know this? We had a bunch of tables, so distributed tables. So there's a bunch of distributions, and your data gets distributed, and you use a hash column to do the distribution. Someone had decided that they were going to update the values in the distribution column for a distributed table that had 100 million rows. And they could not get that to go during the day, and they decided, I know what I'll do. I'll push go on it after everyone's left work. And when the automated shutdown happens at 9 o'clock, we were shutting our environments down at 9 o'clock to save a few quid overnight. It'll be done by then. It really, really, really wasn't done by then. I am amazed that you are allowed to update the values in the columns you're using to do the hash distribution. There's a little tiny warning about not doing it somewhere in the documentation. That warning should be in 5-foot-high letters of fire. Or ideally, the database should say, you really don't want to do that. So yes. You can, if you do your automation, there's a couple of things and a couple of queries you can run to decide what the hell's going on. If there's lots of open transactions, what the scale of those transactions are, and various other bits and pieces, and you can decide not to pause, try and pause it again an hour later. There's lots of things like that that you should probably think about doing, particularly if you're going to automate it. Okay? It's worth remembering that a scale is a pause, followed by a resume, effectively. And again, if that pause happens with a big transaction taking place, the resume suffers exactly the same transaction rollback problems that I've been describing. Okay? It's way, way, way simpler to just buy a reservation, particularly at scale. Yeah, buy the reservation, run the thing at the reservation level. It's significantly cheaper. Stop scaling the thing, stop pausing the thing, just run it end to end. Backup and restore. So you can take a snapshot, and taking a snapshot takes a few seconds, somewhere between a few seconds and tens of seconds usually. But that's not as useful as you think. Unfortunately, what you need to do is you need to be able to do the restore. And the restore is a storage operation, obviously. Yeah, and the thing about this is all magic in the cloud, and under the covers, you don't know, is it restoring to the same disks that are nearby, disks in the same rack, disks in the same corridor, I don't know how they're actually arranged, disks on the other side of the data center. You've got no way of doing that, of understanding that, and that restore time can vary. It can vary a great deal. Scales are significantly more predictable, except when you've got a transaction that that you're rolling back because of the way that you're doing it. But restores, as I say, the times for these vary very significantly. Okay? We did have restores that took 8 hours, 10 hours, 12 hours on occasions when we hit things. It has to be said, towards the end of our experience, it got significantly better. Not entirely sure why, but it would be very nice if we could reserve some storage right next to where you are so you can run some restores. One of the things, essentially our approach with this was that we ran overnights, we ran the restore yeah, immediately. We then run the processing part of our process that starts about 4 or 5 o'clock in the morning. And again, we restored that instance. And then we essentially took a restore at the beginning of each day's operations. And we literally restored each of these immediately. You know, you take a snapshot and start the restore process. That way, once it's finished restoring, you pause the environment. The environment's there, it's available for you if you need to roll, if you decide that you need to roll back to how it was this morning or how it was yesterday morning, that's what you do. When you're doing a restore, you don't need to restore to the same scale. So we were running at 3,000 or 6,000. All of our restore instances were running at 100. Yeah, and we just literally do it. There's a pile of REST API stuff that you can do, so you can do all of this through ADF. And the REST API. And the great thing is you're restoring back to a completely different instance. So you can list all the restore points, there's a bunch of PowerShell, various other bits and pieces. And when it comes time to restore, essentially what you do is you actually rename the database, because renaming the databases takes almost no time at all. The great thing about those guys is that the thing you have restored, yeah, if you decide to scale that, it'll scale pretty reliably and pretty quickly because it's not a storage operation anymore. It's just reprovisioning the compute because you've not got a load of open transactions on it, unless you've got people using your restored instances to do things, which they really, really shouldn't be doing. OK. One of the other things you can do is you can basically do slightly more granular backup and restore. The create table as goes like blazes, and create external table as goes like blazes. Give yourself, write yourself a couple of little stored procs like this. If you drop me a note, I'll drop you the GitHub repo where I've got these sprocs, and they literally just take a table, stick it in a backup schema. Take a table, stick it in a backup schema. Take a table, stick it in a backup schema, or stick it out onto Azure storage. And what you then do is you just keep them on Azure storage, or you keep them in the backup schema for a little while and tidy it up after a few days. This gives you the ability to roll back a table rather than a 60 terabyte data warehouse because you've screwed something up. OK? Much, much more useful. What else was I going to say? One of the things you need to watch out for, particularly if you're restoring using this approach, the instances, the reason that we restore our instances and then pause them immediately is that you can't turn off geo-replicated storage once it's turned on. So what will happen is it will restore your instance, and if you leave it running, it will replicate all of the storage. It will geo-replicate all the storage, and that's got a fairly significant cost to it when it's 60 terabytes of stuff it's geo-replicating. OK? You run a pipeline, you do your restore. As soon as the restore is complete and everything's good, you pause the instance. If you ever need it, when you spin it back up, remember to turn the GRS flag off. Heaps. Everyone happy that they understand a heap? Or a heap in dedicated storage? Or dedicated SQL pool. So a heap in dedicated SQL pool is literally kind of a bunch of unstructured data. Usually it's got a distribution of some form, usually round robin. And it's actually the way that Microsoft recommend that you load stuff, because you can just write into them and write. And it's absolutely fantastic. And our load process was kind of take stuff from a source system, stick it into a staging table. Staging tables were always heaps. So, and then move it onwards. So right at the very beginning of your load process, you would truncate the staging table. Truncate the staging table, load up all the new stuff into it, push it downstream into your ODS or your dimensions or whatever the hell, and then repeat that trick multiple times. While we were backloading from our source systems and our Netezza environment, we were running about 1,200 loads a day in a fairly short 6-hour window because of business constraint. And we were basically truncating and loading, truncating and loading, truncating and loading, truncating and loading. And then one Monday afternoon, we saw this. And this is a very, very bad message, because this is telling me that my database has run out of storage. Anyone know what the limit is? What's the maximum amount of storage you're allowed to have? There's a hat in it if you can give me the number. Mark's not allowed, he's already got a hat. It's 240 terabytes. And I was like, seriously? I've loaded 240 terabytes of data? Are you absolutely 100% sure? I went in, and I used sp space used, which still works. The fact that sp space used and a bunch of other views are still supported, if you go onto the documentation pages, eventually you will be sent to the old parallel data warehouse documentation. And the parallel data warehouse documentation is actually still immensely, immensely useful. There's loads of bits and pieces in there that are still valid, because fundamentally that's what that's where the products come from originally. And I was like, 236 terabytes? Are you kidding me? There's no way I've loaded that much data. I was absolutely 100% convinced that that was not true. One of those resources I pointed out right at the beginning has this view, and this is to do with summing your database table sizes. Yeah, so it gives you a table size summary. And the table size summary came to 80 terabytes. So I've got something telling me I've used 80 terabytes, and something telling me I've got 236 terabytes, and no space to put anything, any new data. If you go in, you can take a look. You can look at a bunch of things inside the performance counters, and the performance counters will give you this. Sorry, I need to figure out how to pause this. This isn't the data that we had at the time. The data we had at the time showed every single one of these at 4 terabytes. Yeah? And that's the reason why 4 terabytes times 60 distributions, 240 terabytes, that's why it's a limit. This is, I'll ask a question about this later. But essentially it showed that every single distribution was absolutely full to the gills. And the reason it was absolutely full to the gills is because buried in the documentation is an optimization. When you truncate a heap, it doesn't truncate the heap. What it does is it says, there's a bunch of pages allocated to storage. I'm not going to use those pages. I'm going to put them on a heap, on a list of stuff to clean up, and I will just give you a nice new empty set of pages to play with. Thank you very much. And there's a task in the background that goes along and cleans up those pages later and makes them available to your database. Yeah? That's a task that runs in the background. When you're running 1,200 processes, moving 20 terabytes of data in a few hours, repeatedly for days, the process doesn't keep up. And what happens is you end up with an awful lot of pages in the cleanup that the cleanup task just can't deal with. That's the way your database thinks it's done 236 terabytes. Yeah. So it happens after the event. Again, if you go into the documentation, what you will find is there's a trick to managing heaps and rebuilding to reclaim the wasted space, and it's this alter table whatever rebuild command, which I had never seen. I've been doing this for a while, about 25 years, and I had never even seen this command ever in the history of the universe. I think that's not true. I think it was there in the original versions of SQL Server, and you've got to go back to the numbers where it only had one number. But if you put this on the end, it basically skips that cleanup thing, yeah, and it actually reallocates the pages immediately and instantly.
I've used that command before, where you remove forwarding pointers from heaps in SQL Server.
Yeah. Yeah, it's certainly been around, but it's not something I was particularly conversant with. After Microsoft successfully extended the cleanup period and got the cleanup task and gave it a bunch of resources, and we got our database back down to something approaching a reasonable size, we stuck this guy in, didn't see the problem anymore. So if you are truncating big heaps, use this. One of the other things that you're going to come across is the fact that in the cloud, everything changes all the time. People who have far more network voodoo than me tell me it's always DNS. Yeah. What happens is stuff just fails. Yeah, stuff goes wrong. There's a little blip. These aren't outages. These aren't things you'll see anywhere. It's just stuff not being terribly happy for a few tenths of milliseconds set to seconds. Yeah. As a result, you have to set the retry. Yeah. You should really set retry on your tasks, a little retry delay, and retry at least once, if not twice. I'm loving the 12-hour default, 12-hour runtime default for things that may or may not time out. That's absolutely fantastic. If you've got a chain of things and you start it early in the day, you may not find out that it's not done its thing until long after you've gone home. Can anyone remember what that used to be? I mean, it's 12-hour default now. Anyone remember what the default timeout period on a data factory task was when you just literally dropped it on? 7 days. That man wins a hat. 7 days was ridiculous. These are a list of the random errors that occur, yeah, that you will see. Cannot open database, whatever requested by the login. And that's funny because there was a pile of ADF running right next to it that successfully got to that database. Cannot login failed for user, which is funny because in the same second, other ADF tasks successfully logged into that database and logged in as that user. Yeah? And this is just because underneath, sometimes the components struggle to talk to each other. And that's why you put the retry on. Yeah? Because otherwise, these things plague you constantly. That constantly. Okay? It happens all the time, continuously. Yeah? It's just micro blips in the environment. This is kind of how this thing works. Okay? And you can see some days it's worse than others. I suspect Microsoft were patching something that day. But most days it's in there. Yeah? If you're running relatively small workloads, you might not see this that much. But, you know, again, we're running something like 1,800 processes over a 5-hour period. Yeah? So we see a bunch of those. Let's go. Idempotent. If you read anything about the cloud and you read anything about Azure functions or all of those things, you will see this word. You will not see it in the Azure Data Factory documentation very much. So I'm going to keep going backwards and forwards here to stop it going forward to the next slide. Anyone give me a good explanation of idempotent in under 5 minutes without using glove puppets and diagrams? So this is idempotent. Yeah, basically it means it's got to be safe to run twice. Okay, safe to run it, and if I run it again, it's got to end up being in the same state at the end. Gross oversimplification. I'm sure there are computer scientists that will put me down and kill me for that, but that's kind of where that comes from. One of the things that you have to be aware of is that Azure Data Factory fundamentally is Spark. That's actually what it is under the covers. You know, a little clever UI that does various bits and pieces, its own little JSON language for various things. But what it's doing is it's turning stuff into Spark. And I have no idea what Spark is. Simon Whiteley and co will give you far more information on Spark than you will ever want to know. As far as I'm concerned, it's a bunch of magic pixies that are down there running around doing their insane thing. But one thing I do know is that when you create a job in ADF, there's effectively a coordinator. There's a little coordinator task that sits there and does its funky thing. Yeah? And what it does is it spins up worker threads and does things in parallel where it can, and it decides how many workers it's going to spin up based on the workload. And that's one of the ways it scales and does all the very clever things that it does. So when running a stored procedure, a worker is created, and the worker runs the stored procedure. That's the little worker goes off and does its funky thing. But Spark is built on Azure, and Azure has blips. So in an ideal world, this is what happens. Spark king to peasant to a running sprock. Yeah? Everyone cool with that? Yeah? However, what sometimes happens, whoops. How many slides can you go in one go? Come on. What sometimes happens is your peasant dies. Yeah? And what happens is, after a few seconds, about 30 seconds, the Spark king goes, that peasant has died. I will start a new peasant and tell it to get on with it. And as long as your peasant's died, that's entirely fine. Yeah? Peasant dies. However, sometimes what happens is your peasant has gone AWOL because the peasant and the Spark controller job can't talk to each other anymore. At this point, the peasant here is sat here running the stored proc, but the king does not know that the peasant is sat there running the stored proc or lookup activity or script activity, so it starts a new peasant. Yeah? That makes sense? Yeah? You get a nice, shiny new peasant. Can't see this in the ADF logging. This will not show up in the ADF logging. The only place this will show up is if you turn the logging all the way up on the SQL instances and get into logging analytics. And you will see that the sprot was run, and then the sprot was run again. Yeah? Does anyone want to guess what the next scenario is? That's even worse than this. What happens if when it starts the second proc, the first proc hasn't finished running? If not only does your stuff need to be idempotent, it also needs to be a singleton. It should run one instance of it at a time, at best. I told you, none of this is in documentation for Azure Data Factory. That's not entirely true. This information here, running stored procedures more than once. Usually this happens because of a batch VM reboot, because of a forced OS support. This is hidden in the small print when you launch the support ticket to say, why is my stuff running more than once? Yeah? But it doesn't happen very often, 0.001% of the time. Yeah? And if you're not running very many, you might not get very many of these. Yes? This is also the place where it mentions it's a good idea for your stored proc to be idempotent. Doesn't mention it anywhere else in the documentation, only here in the notes when you try and raise a support ticket because you've got a problem. So that's distinctly suboptimal. You'll notice no mention of the need for a singleton. Yeah? It's 1 in 100,000 executions. Yeah? That percentage is 1 in 100,000 executions. We do about 1,800 processes a night, so we would expect to see one of these every 55-ish or so days, once every 8 weeks. Hands up everyone who thinks we see this once every 8 weeks. Yeah. Wrong button. We see this a lot more than once every 8 weeks. And some days, we see it 20 or 30 times in a given day. Again, we probably hit a patching cycle on the Spark clusters that we were using. We're using the Azure hosted generic runtimes. Yeah, you can use your own runtimes. Yeah, you can spin up your own dedicated Azure hosted runtime. It'll still happen. It's a joy and a pleasure. All right. As I say, incredibly, incredibly hard to spot unless you've got a load of extra login and you're monitoring your stuff like a hawk. And you should do that with all of these things. Fortunately, it's relatively easy to fix. You can write yourself a little stored proc, and the stored proc goes at the top of every single stored proc. And as a stored proc starts, it calls this and says, am I already running? If I am, I will die. Yes? And this is the select query inside the stored proc that's doing the test. It literally looks into the exec sessions, and looks into the weights, and looks for the object name. Yep, the object name will be the name of the stored procedure. I'm almost entirely 100% convinced that this is not really supported. So this is one of those, you can go in there and play with the DMVs, and it'll work. This works on dedicated SQL pool. It does not work on normal Azure. So, yeah, you're going to need to think about doing singleton patterns for any big, decent, long-running operations.
Can kill the first one or the second one?
It doesn't. It just tells you whether it's running or not. You decide what the hell you're going to do. Yeah. If it returns 1, you're the second one. Yeah. And you've got to handle that and figure out how to do that. And if you cascade that error up through ADF, that gets really, really interesting. And there are no good patterns for figuring out what the hell that is. At scale, concurrency is everything. Yes? You can't afford to be doing one thing. You've got a really, really big box, lots of how many concurrent queries you're allowed, the maximum of grants, and the various other species. This is just a table off the Microsoft documentation. But you've got a lot of processors and a lot of RAM to run one thing at a time, or 4 things at a time, or 8 things at a time. You're not going to be running 8 things at a time. You want to run everything. And on really, really big enterprise systems, you're running them at 6,000 because you need all 128 concurrent execution slots for your users, for your finance nutcases that run things on this environment at the end of the month. I'm going to talk about a bunch of things. these are the URLs to the links about workload management. This guy does a pile of stuff that's really interesting about workload isolation. This fellow apparently knows something. I'm not sure who he is. Sorry. I'm not sure who this fellow is, but he does know a bit about Synapse. And the architecture of what's going on in the pools is really, really interesting. And again, is kind of fundamental to an awful lot of this kind of parallelism and wanting high throughput concurrency. Our ADF load pattern kind of looked like this to start with. What we do is we'd load from the source, load process, staging, polybase, copy, blah, 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 blah. Doesn't matter whether you use the copy command, doesn't matter whether you use the polybase command, doesn't matter whether you use the bulk insert command, and the upsert command didn't even exist when we started. But what tends to happen is it tends to start the connection at the Synapse end as soon as the process starts. And it holds it open until all the data's arrived and it'll do the commit. So if this source thing is delivering data to you really, really, really slowly, you're holding a connection open onto your Synapse pool. You may only have 64 connections. You may not have even 64 connections. You may have significantly less than that. And that means you can only load a certain number of things in parallel. One of the things you've got to be careful about is here at the source end, you've got the concurrency problem again. If I'm issuing 20 queries against the same Oracle database, it gets slow really, really, really fast. And that's one of the reasons why you need a really, really good ELT framework that lets you govern concurrency on both sides of the problem. Okay? So, this can be a real challenge. You know, as I say, you're never running one. You're always running more than one. You're always running as much stuff in as you possibly get. That's a concurrency graph with the dreaded orange bars. The orange bars are queued queries. They're queries that wanted to run and could not find the memory grant or concurrency slot to run in. That's actually a pretty good day for us. Once upon a time, the whole thing was just awash with orange continuously. We cheated. We broke our process into an explicit staging process. So all of our sources wrote into a Parquet file because we then didn't really care about how long that took. Yeah. What that does is just pour Parquet files onto storage, and then we had a completely separate set of processes that grabbed that Parquet and threw it into the data warehouse. And the strange thing is, I can run more of these, because these are running slow, and still these guys will just absolutely whiz round. Typically, particularly on our, again, it'll vary by environment, because it depends on networking and source system and various other bits and pieces. The time to actually load and process into the Parquet was anywhere between about 3 and 15 times longer than the actual Parquet load into the dedicated SQL pool. Parquet into dedicated SQL pool goes really, really, really fast. If you're using ADF, yeah, use Parquet files. Don't use awk files. Don't use Avro files. Don't use any of the stupid other formats. Use Parquet files. And the reason to use Parquet files is because they just work. And how do I know they just work? Because somewhere buried in the ADF documentation, there's a little note about a couple of things you can change to do with the dynamic mapping engine. And the fact that they've had to build a second dynamic mapping engine tells you the first one was broken beyond repair. And the reason it was broken beyond repair is if I had an awk file and a Parquet file and I was trying to load them into the same table, Parquet file will ignore columns and say, yes, you can have extra columns as long as they are null values, and the awk file will go, hang on, I've only got 5 columns in the awk file, there's 15 columns in the destination table, I am not loading that. And the awk file will sometimes decide, I'm going to be case sensitive. I know it's called ID on that side, but it's called capital I, lowercase d on that side, and they are not the same. So, yeah, ADF, mapping engine. Do you want to take some notes for the ADF team? Scroll them down. Yeah, you might need quite a lot of paper. What we do is we use workload groups, and we use workload classifiers, which was I've kind of referenced in the previous notes. Go and read their blogs and the various other bits and pieces. And the idea behind this is that you use a workload group to grant different levels of resource. So 5% to some things, 10% to other things, 20% to various things, and you mix and match so that some things get more resources than other things. And that's, you know, hopefully a sensible thing to do. I have reproduced this table, and this table doesn't really exist. So when you're on a 3000, you get 6 nodes, you get 1800 gigs of RAM, and the minimum resource allocation is 1.5%. That's 27 gigabytes of RAM. Even the minimum is pretty big. Yeah? That makes sense? And again, Data warehouses, as is typical, I've got a table over here. That's my product table. It's got 300 rows in. I've got another table over here. This is my customer base. It's got 4 million rows in. Over here, I've got a fact table. It's got 11 billion rows in it because there's loads of stuff changing and the different scales, yeah? Even up to low single-figure millions, entirely reasonable to process those using the minimum, yeah? Only the monsters need to be worried about. And the monsters will block and spool and do all sorts of other things in exactly the same way as they do in conventional SQL Server. One of the great tricks in Data Factory is that you can have dynamic link services. So what you can do is you can create your link service, and you can actually just look up a secret at runtime. So it looks up a secret at runtime, and the secret at the runtime has a connection string in it. Yeah, it's not great because it's got a username and a password in it, because but that's not great. But at least it's in a key vault. So what you do is you set a data set up. The data set has a key vault secret name. The link service has a key vault secret name, and you push the key vault secret name in at the start. Yeah. And the really neat thing about this is, what you can do is you can have different connection strings, because you can build yourself 2 users. A regular user and I'm going to do something really insanely big user. Yeah? 2 different connection strings. Connection string goes in as a parameter to the pipeline. Pipeline passes it to the dataset. Dataset passes it to the link service, goes and gets the information from the key vault, pops into the thing, comes in as a particular user. Workload management says, you're the regular user, you get the minimum grant. Oh, look, you're the insane user processing one of the really, really big tables. You'll get a nice resource grant. And that's how you can manage to get things and govern things to run more concurrently. So now we load all the things into this side, but the important thing is on that side of the fence, not only do I run things faster, but I can run small things, I can run big things, I can run different things, and I can allocate resources where they're needed. The monster tables can be made to go faster because I can just give them a load more resource. Yep. Make sense? This is our utilization graph, by the way, for a typical load. It keeps forwarding on me. This is our utilization graph, and as you can see, we flat spot it like crazy in terms of the storage, but actually our utilization inside the workload groups is really, really good, and that's because we've broken stuff into different groups, and that's just for the automated processes. This is an overnight thing. There are no users in this data, no user queries in this data. Okay? Right. Index and stats maintenance. You are going to have to use index and stats maintenance. Yes, Bob Duffy has written an excellent kind of toolkit that really, really works and does most of this work for you. Don't reinvent the wheel. My only criticism of it is it's aimed at small instances, because you run a stored procedure, it creates a list of things to do, and then it does them one at a time. Yeah? So all I did was, instead of it creates a list of things to do, it puts them in a table, and then it starts an ADF process that runs 10 of them at a time. Yeah, because that's the only way of getting through the number of tables we've got. We use, did I mention we use CI/CD? We use CI/CD in this project. Yeah, CI/CD project, an Azure, an SSDT project in Visual Studio with 8,500 tables. That's a big bunch of laughs. Hmm? Yeah, that doesn't work either. There's a bunch of tricks around that you need to do. And one of the things that we have is Bob's stuff uses DMVs, as all of them do. There's a very similar one on the Azure toolkit, which isn't as good. But they all use the DMVs. And the DMVs, when you've got 8,500 tables, can get slow. So what we actually do is we cheat at the beginning, and we materialize the DMVs into a bunch of tables, and then we just point the queries at the tables instead. Watch out for pointless CCIs. Yeah, clustered column store indexes. 10-row table that was set up as a CCI. It's like, that's never going to work. And also, watch out for big replicated tables. Lots of people will replicate a table to make queries go faster. Yeah? And they'll replicate it because it's a new table and a new piece of a solution. And it's only got 100,000 rows in now. 6 months later, that table is 10 gigabytes. It's being replicated across your entire environment on every single distribution. It's not 10 gigabytes, it's 600 gigabytes. 10 times 60. Okay? All because it's been growing. Watch your replicated tables, watch them for size. At some point, you're going to have to switch them and start distributing and the various other bits and pieces. It's it happens. It's definitely something that appeals. I can't believe we've got to 7 and I've still got minutes to go. Because it's a Netezza project, I'm going to tell you about this. Netezza has these amazing hidden columns. It has a row ID which never changes. What a great idea that is. And then it has a transaction ID. Please stop forwarding automatically. And then it has a transaction ID and a data slice. And the great thing about the transaction ID is the create XID and the delete XID update when you change data. So this is really, really good for grabbing a table and just grabbing the stuff that's changed in that table since the last time you loaded it. When you're doing your backload from your source system, you will be doing most of your backloads from the running data warehouse in your organization, because that's the only place the data exists, because those source systems left the business a long time ago. I did mention we're doing 7 things, managed to get to 8. There are a bunch of others, yeah, and I'm going to write articles about these. They're all kind of almost there. If someone wants to give me a hand editing them, I'd be very grateful. And all of these are sat in a GitHub repo. If you want the details, I'll send it out to you. There's a bunch of things in there that hurt you and burn you. Hopefully I did the ones that are, A, the hardest to see and the hardest to find, and hurt you the most. Yeah, that's kind of how I prioritized the 7 that I decided to cover. Everyone cool? Everyone kept up? 42 minutes, 64 slides. I think you all deserve a round of applause for just listening to me rant, to be brutally honest with you.